So here are some examples of finding of some relations and finding the domain and range. So here's relation 2. Remember, relation is a set of ordered pairs. This one just happens to have 3 points in it, right? So 3 ordered pairs, and I just listed them. The curly brackets is used for lists. These curly brackets here are used for lists. They're used for some other things as well, but here it's being used for a list of 3 things. So the domain is going to be the set of all the possible first coordinates, so 1 and 2. And when you're listing these, you don't list the same thing twice. So it's just 1 and 2. It's a set. 1, 2. Now that's an unordered pair. You could write 2, 1. It means the same thing. It's just a list of the things that are in the domain of R2. All right? And again, the 1 occurs twice, but we don't indicate that in the domain. Just like we didn't on relation number 1. So what is the range of this? It's going to be the set containing 2, 1, and 5. And I can write them as in that order, or if I wanted to, I could write them in numerical order, which there seems to be gravity pulling us towards writing them in numerical order, but it doesn't matter. They're both meaning the same thing. So notice the range has 3 numbers in it, and the domain only has 2. So example 3 is relation 3. Now this here is called set builder notation. So this is another use of the curly brackets besides a list. I've got, first we say what kind of objects are in the set. So these are points in the real plane, right? And then this line separates that from the rules that these things have to follow to be in this set. In this case, there's only one rule, y equals x plus 1. So this is just a fancy way to write the equation y equals x plus 1. Well, it's the solutions to the equation y equals x plus 1, right? It's called set builder notation. Usually we read this way. R3 is the set of all ordered pairs x, y such that, we read the vertical line like such that, y equals x plus 1. Okay, so it's just going to be the points on the line y equals x plus 1. That's all it means. So I graphed it there. And remember, if I don't put dots on the end, it means it keeps going. Your textbook, I think, might put arrows on it, which is considered a little goofy at the college level. But it's okay. It's clear. It's clear what it means. It keeps going. Okay? So what's the domain going to be? Well, the set of all possible first coordinates. Well, you can get this first coordinate, right, at that point. You can get this first coordinate at that point. And since it keeps going, I can get any first coordinate I want. Right here, I'd be down here somewhere. Right, the point would be down here. So the point down here has this as the first coordinate. So hopefully you can see I get all real numbers. Another way to see this, take this line and just flatten it straight down onto the x-axis. And you'll see you get the whole x-axis, which means the domain is all real numbers. And if you do that with the y's, flatten down to the y-axis, you'll see you also get all real numbers. So the domain and the range are all real numbers. So I already said this, but I wrote it out so you have it on the PDF, so that if you look at it later, you'll see it there. You won't get confused. So negative infinity to infinity, which is also, this is the name of the set. It's a R, what's called the black bolt R. It just has an extra line, vertical line through it. It means all real numbers or all real numbers. This is interval notation. Sometimes they ask for interval notation, so you need to use this. Okay? And the range is the same for this one. So this will be the same for all lines except for vertical lines and horizontal lines. Those are the ones that'll be where you won't get minus infinity to infinity for both domain and range. Okay. So I just graphed, you can think of the domain as being this orange stuff, and the range as being the y stuff, as being actually on the y axis here, vertical axis. Okay. Example 4. Relation 4 is the set of all points x comma y such that x squared plus y squared equals 1. Well, we already did this kind of thing. That's a circle, center at the origin, because it's x minus 0 the quantity squared, y minus 0 the quantity squared, right? With radius 1. So that's called the unit circle, actually. It becomes very important when we do trig. That's a unit circle. It's, when I say unit circle, U-N-I-T. Unit circle is the circle of radius 1 with center at the origin. So what's its domain? Well, take this and flatten the whole thing onto the x-axis, and you get everything from -1 to 1, including -1 and 1, right, for your first coordinates. So there you go. Flatten it onto the y-axis, and you can see the y-coordinates you get for all these points go from -1 to 1. Always go from the smaller number to the larger number. Left on the number line, right on the number line. I'm thinking of this number line as the up being to the right, I guess, on the number line. Anyway, so the range happens to be the same. That's because the center's at the origin. If the center was somewhere else, then the domain and range could be different, right? Okay.